When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is, it always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story about where it all started. Sir Tim Berners-Lee, a physicist, often thought about how he and his colleagues from around the world would share information. You are so used to browsing information online that it might seem a silly thing to ponder about. Actually, that question was very relevant at the time and started the development of HTML. Would you like to explore the very first web page? I know just where to find it. The first web page was created in 1989 by Sir Tim Berners-Lee. He worked at the European Organisation for Nuclear Research, or CERN, and originally proposed HTML. The first version of HTML was released in 1991, along with the first web browser and web server. HTML stands for Hypertext Markup Language. But what does that mean exactly? Hypertext is text which contains links to other text. Markup refers to tags and elements used within a document. For now, let's just focus on some of the basics of HTML. HTML is simply a text file with a specific structure that consists of elements and tags. Also take note that HTML files usually have a .html suffix. For instance, when you visit a website, the first page that is returned to the browser is often called index.html. Now, let's explore what HTML tags and elements are. Each HTML element consists of an opening tag enclosed in angle brackets. For example, to create a paragraph, you type a left angle bracket, the letter P for paragraph, and then a right angle bracket. Most elements are paired with a closing tag, which has a / after the left angle bracket. For example, you close a paragraph element with a left angle bracket, a /, the letter P, and a right angle bracket. HTML elements usually have some content inside them. For example, between the opening and closing tags of a paragraph, you add the text of the paragraph you want to write. HTML elements can also contain other elements. For example, you can add an italics element inside a paragraph element to make text appear in italics. But elements can also be empty or self-closing, meaning they do not have a closing HTML tag. One example of a self-closing element is the line break tag. You can add a line break tag in a paragraph tag to move content to the following line by typing left angle bracket, the letters BR, then right angle bracket. At the end of a self-closing tag, you simply add a right angle bracket, but you can also close the right angle bracket by typing a / right before it. Now that you know what elements and tags are, you will explore what HTML standards are. The rules and structure for elements and tags are known as the HTML specification. The HTML specification is maintained by the World Wide Web Consortium, or W3C as it is commonly known. Whenever the HTML specification changes, a new version of HTML is standardized. The current version is HTML5. So to summarize, HTML elements with their opening and closing tags in angle brackets build up an HTML document. These elements form the structure of a web page and describe to the web browser what to display. For example, the browser reads an HTML page that has an image tag to display an image file called icon.png. Next, it reads a P tag to display a paragraph under that image. But the browser reads the HTML document and displays the web page to the user in a very basic format. Now, if you want to tell the browser how to display the web page, you should use CSS. You will learn more about CSS in this course. By now, you have learned how HTML tags are used to create elements that build the structure of a web page. You will have an opportunity to explore HTML in action in this course.
In this video, I will guide you through the blueprint of an HTML document. I will create a very simple web page for a restaurant called Little Lemon. The great thing about HTML documents is that you don't need the web to view them. Yes, they don't have to be hosted on a web server for you to view them in your web browser. You can save HTML files on your computer and view them locally with your web browser, almost like eating takeaways at home. So by the end of this video, you'll be able to identify the structure of an HTML document and create a basic web page. To create an HTML file in Visual Studio Code, I right-click in the Explorer panel and select New File, name it index.html. By now, you know that HTML documents are made up of elements and tags. But before I can add elements or tags, I first need to create the standard HTML structure, which starts with the doc type declaration tag. This notifies the web browser that it is an HTML document. Next, I create the HTML tag, which is also known as the HTML root element. And inside the HTML tag, I add the two main elements, the head and the body elements. It's important to know that nothing inside the head element is displayed as a web page in the web browser. In the head section, you add information or metadata about the HTML document. It is not part of the content of the web page. For example, inside the head tag, you always create the title element. This is the title that is displayed in the web browser tab. I can also link to CSS files and define meta tags in the head section. Meta tags can, for instance, specify the description of the web page, keywords for search engines, and the author of the web page. Next up, I add the content of the web page inside the body tag. The body can contain elements such as headings, paragraphs, images, and videos. Okay, let me start by adding a main heading on the web page by using the h1 tag. Inside the h1 tag, I type the heading Our Menu. That's good. Now I need to start creating my menu. I want to add 2 items, so I add 2 subheadings. For this, I use the h2 tag. The menu items in the subheading are falafel and pasta salad. But first, I need to save the file by pressing the keys Ctrl and S, or if you're on a Mac, Command and S. Now I right-click on the index.html file in the Explorer panel and select Reveal in File Explorer. If you're not using the Windows operating system, this may be called Reveal in Finder or Reveal in File Browser. Now the file browser opens and lists the file. I double-click on the index.html file and it opens in the web browser. Great, it's all here. The title that displays in the Browser tab matches the title that I added to the head section. And the content is displayed in the browser window. But it's still a bit empty. I go back to Visual Studio Code and add a short description for each dish. I do this by adding the paragraph tag below each subheading H2. Let's imagine a nice falafel. I type chickpea, herbs and spices. What goes in a pasta salad again? Lettuce, vegetables and mozzarella. Yummy. I save the file to update the changes and open it in my web browser again. There you go. Now the ingredients are also included in the menu. Some of the best websites are websites about food. Whenever you need some inspiration, search for food website ideas online. You'll be fascinated. Now that you know some basic HTML tags, try to identify where they were used in those websites. There are many HTML tags that you can use in your web pages, but you are now familiar with a few elementary ones, and I encourage you to start practicing with them. Best of luck.
By now, you should know how to build a basic web page. But how do you build a website? Remember, websites consist of multiple web pages linked together. To link pages together, you use the anchor tag. Anchor tags create hyperlinks, or links as they are commonly known. In this video, you will learn how to link different web pages together to create your own website. In my project folder, I now create a second web page for Little Lemon that will contain the address of the restaurant. I right-click in the Explorer panel to create a new file and name it location.html. I use the same file structure created in my index file, but add new content. I add a new h1 tag for the heading and type our location. Next, I add a paragraph tag and insert the address 123 Home Road, Main District, Capital City. I press Ctrl and S to save the file or Command and S on a Mac. Now that my new file with the restaurant location is created, let's navigate back to index.html file to add a link from there to the location.html file. Below the last paragraph tag, I add the anchor or A tag, followed by the href attribute or hypertext reference. Now I need to specify where the hypertext reference should link to. I type the file name, location.html, so that my index.html file will link to it. Within an A tag, I can also add a descriptive text that is displayed as the link name on my web page. So I type our location. The text our location will now display on the web page in the browser as a clickable link. Let's test if it works. I save the file to update it with the changes and open it in my browser by right-clicking on the index.html and selecting Reveal in File Explorer. If you're not on Windows, this may be called Reveal in Finder or Reveal in File Browser. Then I double-click on the index file. The words our location are displayed in blue in the web browser. Success! If I click on the blue link, the browser opens the location.html file. You can now link different HTML files together to create your website. Best of luck. Imagine your favourite social media site. If it was just an HTML document, users would be able to scroll the page, look at pictures and read text, but they wouldn't be able to log in, like posts, or get notifications for new messages. In order to allow users to do these things, they need to be able to interact with objects on the page, such as the reaction icons or the comment button. Or, let me put it differently. An HTML document must be represented in a certain way so that JavaScript code can query and update it. To do this, we use the document object model. In this video, I will unpack what the DOM is, how it is created, and how JavaScript interacts with the DOM to make sites dynamic. When your web browser receives an HTML page, it constructs a DOM to represent it. DOM stands for Document Object Model, and it is simply a tree structure or model of the objects in your HTML file. To understand the DOM, I want you to think of a simple HTML page. Remember that an HTML document has opening and closing tags for the document and the head, and inside the head tags you have title tags. Then you have the body, and inside the body there might be elements such as div tags. Okay, now let me guide you through how a DOM would be generated. The DOM has a series of objects, each representing a single HTML element. At the root of the DOM is the HTML object, and it contains the head and body object. From there, the head object houses the title object, and the title object contains its text object. The body object contains the two div objects. The first div houses the heading 1 object, which again houses its text object. The second div object contains the paragraph object, which contains its text object. In summary, all the elements in the HTML file are represented as objects in the document object model. I just took you through a very simple web page. Web pages typically have hundreds of elements. Can you imagine how complex the DOM of a highly interactive modern web page is? You as a developer can use JavaScript to access and modify the DOM to make your web pages dynamic. In fact, in a later course, you will learn how to access and modify the structure of the DOM and its elements in different ways. Now that you know what the DOM is and how it is referenced, let me briefly explain common DOM and JavaScript uses. For each element, you can access the HTML attributes and content. This means you can update the existing content that is displayed in the web browser. For instance, you could write some JavaScript to update the seconds, minutes, and hours of a digital clock on a website. Or, if you develop a movie streaming website, you can write code that responds to user actions such as clicking, mouse over, scrolling, and so on. In this way, you can allow a preview of the movie to play when the user hovers the mouse over the movie's poster. Or, you can think of a login page. When users click the login button, you can disable the button so that it cannot be clicked again. The web application would bring them to a new web page or would re-enable the button if a login error occurred. You can even add DOM objects to dynamically add new HTML content to a live web page. For instance, you can add an error message to a form if the user inserts invalid data. DOM objects can also be deleted, which will remove the corresponding HTML displayed in the browser. Think of a to-do list on a website. You can remove an item from the list when the user clicks on it. Another major use of JavaScript and the DOM is to animate the HTML elements. This can be quite complex depending on the animation, but there are many libraries available that aim to simplify this. For example, when a page first loads, you can fade in the page contents. Or, when a user receives an instant message, a notification can pop up in the web browser. Many JavaScript libraries and frameworks rely on the DOM. One of these libraries is the React library. By now, you know what the DOM is, how it is constructed, and the wonderful things web developers can do with it to create modern interactive websites. Next time you use your favorite social media site, think about how the DOM is working behind the scenes to change the color of that like button. As a web developer, you should try to ensure that everyone can access and enjoy the internet. Almost like an architect that needs to design a building with ramps and rails so that it is accessible by all. You need to build a website in a certain way to improve accessibility. When the Web Accessibility Initiative, or WAI, was launched in 1997, the creator of the World Wide Web, Sir Tim Berners-Lee, said, "The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. Web accessibility aims to allow people with disabilities to understand, navigate, and interact with websites. A common misunderstanding is that it refers to visual disabilities, but in fact, it includes all disabilities that affect interaction with websites, such as audio and visual disabilities, cognitive and neurological disabilities, and physical and speech disabilities." The W3C Web Accessibilities Initiative develops specifications and supporting resources for accessibility. These are considered international standards for web accessibility. In fact, web accessibility is becoming a requirement in many industries. In 2016, the European Union approved the Web Accessibility Directive, which requires websites and mobile applications of public section bodies to be accessible to those with disabilities. Let's explore some examples of how accessibility is provided to those with different disabilities. People living with disabilities often use assistive technologies to aid them in browsing the web. Screen reader software can read the content of websites and everything that is happening on the device. Screen readers are used not only by blind and vision impaired users, but also by those with reading or learning difficulties. Speech recognition software can turn spoken words into computer commands or dictate inputting text. This is useful for people who may not be able to use a mouse or keyboard due to physical or neurological disabilities. Subtitles and video scripts in videos provide assistance to those with audio and visual disabilities. There are many steps that you can take to improve accessibility. It is good practice to think of accessibility from the beginning of a project. It is a lot harder to rework the project to be accessible later on. If you use the correct HTML structure and appropriate elements as a foundation, it will greatly improve accessibility. In this course, you will learn to structure your HTML properly and follow best practices to support assistive technologies. For example, having text that is not contained within proper tags, like paragraph or heading tags, makes it harder for assistive technologies to interact with the content. Similarly, using multiple line breaks to break up text and add space also presents barriers to accessibility. These are just simple examples to improve web accessibility. However, in the future, you'll probably develop very complex user interfaces, and to make them accessible may not be as straightforward as just having correct HTML. Fortunately, one of the tasks of the WAI is to define the Accessible Rich Internet Application, or ARIA specification. The ARIA specification outlines different techniques to improve accessibility for complex web apps. Now you know about different assistive technologies and that you should use the correct HTML structure and appropriate elements to improve accessibility. I'd like you to think of a physical building and its structure, interior, exterior, and decorations. In a similar fashion, when it comes to websites and web apps, you can think of HTML as being the frame and structure. CSS, however, is the paint, wallpaper, fixtures, artwork, and overall style or look and feel. In other words, CSS tells the web browser how to display HTML elements on screen. When using CSS, there are 5 elements you need to understand. A declaration block starts with a left curly bracket and ends with the matching right curly bracket. In between these curly brackets are the style declarations. Let's cover these elements one by one. The first element of the CSS rule is the selector. This indicates which HTML element or elements you want to style. For example, you can create a rule that uses the H1 selector to change the color of all heading 1 tags in a web page to grey. In this case, H1 is the selector, color is property, and grey is the value of the property. You then create a declaration block using opening and closing curly brackets. The declaration block holds information about the properties and values that you are going to apply to the selector. Now let's focus on the structure of the declaration block. Each declaration is made up of 2 parts, a property and a value. For example, in this case, the properties that you want to change are the color and the background color of the header or selector. Once you have decided which properties you want to define, then you must assign each property a value. The color property gets a value of blue and the background color property gets a value of grey. This will result in all heading 1 tags displaying blue text on a grey background in the browser. By now, you'll have learned that CSS tells the web browser how to display HTML elements on screen. Now, let's work through an example to change a set of heading elements using different CSS rules. I will share a pro tip demonstrating how to install and use the VS Code extension Live Preview to speed up your workflow. Okay, so I'm back in Visual Studio Code here. Did you know that you can add additional functionality by using extensions? If you click on the Extensions tab, you can install the Live Preview extension by Microsoft. If you are running VS Code locally, you can install and use this extension. Once installed, right-click on your HTML file in the Explorer panel and select Live Preview, Show Preview. When you update an HTML file, you immediately notice the changes in Visual Studio Code. In this video, I will demonstrate how to create a CSS file and style some HTML elements. Before I start styling elements, let's create a simple HTML document named index.html. To demonstrate how CSS works, I will use an example created previously. Next, I create a file named style.css. For my web page to use the CSS file, I need to link it to the head element of the HTML file. To link to a style sheet, you use the link tag, which must be assigned 2 attributes, rel and href. The rel attribute is assigned to style sheet, and the href attribute is assigned to the name of the style sheet file. In this example, it's style.css. I am now ready to apply CSS to the index.html file, using style rules that I will write in the style.css file. The selector I am creating applies the CSS rule to all H1 elements. This type of selector is called an HTML type selector. The properties in the declaration block allow me to change how the selected elements are displayed. For example, I'm setting the color property of all the H1 elements to display text in purple. I save the file using Ctrl and S. Notice that this change occurs immediately and there is no need to refresh the web page. So now, what if I want to only style a single H1 element? I can add an ID attribute to the H1 tag that I want to style, and in my CSS file, I create a rule for that ID. Let's do that now. First, I create an ID rule using the hash symbol and then the name header 1. Then I define the CSS properties of that rule to change the color value to green. I apply the rule and save the file using Ctrl and S. Notice that the text for the heading Chapter 1 on the web page turns green. You may be wondering, why does the first CSS rule not apply to the H1 element with the ID? This is because of something called CSS precedence and specificity. This is a complex statement, but basically, the browser will use the most precise selector for an HTML element. CSS has a set of hierarchy rules which dictate which rule will apply to an element. In this example, the ID rule takes precedence over the HTML type selector rule. You can learn more about CSS selector rules and precedence from the additional reading at the end of this lesson. Congratulations! You have now learned about the selection and styling in CSS. Let's quickly recap. After choosing a selector for your styles, you create a declaration block using opening and closing curly brackets. Inside of the code block, you write a declaration which consists of a property value, pair ending in a semicolon. And all these parts together, the selector, code block, and declaration make up a CSS rule. I encourage you to add some CSS rules to your HTML documents to practice selecting and styling. Just like a busy day at a restaurant, a website can easily look squashed and busy. With waiters having to maneuver their way around and customers' chairs up against each other, it can get messy. Good restaurants usually have carefully planned layouts to make customers feel comfortable and allow waiters to move around with ease. Sometimes, creative web development requires thinking inside the box. In this video, I will demonstrate how to use the box model in CSS to create an appealing layout and allow users' eyes to easily flow between content. When an HTML document and CSS style sheet are downloaded, the web browser needs to know how to display the elements on screen. To do this, it allocates a rectangle or box to each element. CSS rules are applied to the boxes of the elements. This is known as the box model. Every box consists of 4 parts: the content, the padding, the border, and finally, the margin. The content is the actual content of the element, like the text or the image. Its size is known as the content width and content height. Browsers are clever, and by default, they will calculate the width and height based on the content itself. Fortunately, developers can control the size to manipulate the layout. You can do this by applying CSS rules to the content, such as width, maximum width, height, minimum height, and maximum height. Let's move on to the padding. The padding extends the content size. Its size is known as the padding box width and the padding box height. The thickness of the padding is determined by the padding top, padding bottom, padding left, and padding right. The padding box width can be calculated as content width plus padding left side plus padding right side. And you can calculate the padding box height by adding the content height, the padding top side, and padding bottom side together. Next, let me show you how you set the border. The border goes around the padding and content. Its size is known as the border box width and border box height. You can set different types of borders, such as solid border or a dashed border. To understand how this plays out practically, I will demonstrate the HTML, the CSS style, and the physical border. To set the border, you can write border width thin, border width medium, and border width thick. Now, let me share with you a pro developer tip to help you calculate the size of your HTML elements when working with the box model. An HTML element is equal to the size of the border box. To get the border box width, you add the padding box width plus the border left side plus the border right side, and you can calculate the border box height by adding the padding box height and the border top side as well as the border bottom side. Lastly, let me show you how to set the margin. Following on from what you have just learned, do you have an idea of what the CSS rule might be? The margin extends the border area to separate the element from its neighbouring elements. Its size is known as the margin box width and margin box height. To specify the margin sides, you write margin top followed by the value. The margin bottom, margin left, and margin right follow the exact same notation. You can also set the padding, border, and margin with shorthand properties, but more on this later. Lastly, let's calculate the size of the margin box. Can you guess how? The margin box width can be calculated by adding the border box width, the margin left side, and the margin right side together. To get the margin box height, add the border box height, margin top side, and margin bottom side together. To easily remember this, think of the content as yourself. The padding is like the thickness of your clothes. The border is like the silhouette or outline, and the margin is the personal space between you and another person. In this video, I've opened the box model for you. Inside it is the content, and around it flows the padding. The border fits around the padding, and lastly, the margin is the empty space keeping elements apart. You will work with the box model in every website you develop, so I encourage you to start practicing with it in your designs. By now, you've learned how CSS styles individual HTML elements. But how does the web browser know where to place the elements on the screen? The web browser's normal way of calculating the position of HTML elements on the screen is called document flow. By default, nearly all HTML elements are organized into one of two categories, namely in block and inline elements. A block-level element will occupy the full horizontal width of its parent element and the vertical height of its content. Each block-level element will have a new line before and after. Therefore, multiple block-level elements will stack on top of each other like a stack of boxes. Inline elements only occupy the width and height of their content. They don't appear on a new line, hence the name inline. Therefore, multiple inline elements can form a row of elements. When coding in HTML, you need to be able to recognize and use block elements. Some examples of block-level elements include the tags div, form, and heading. You also need to be familiar with common inline elements. These include the tags anchor, image, input, label, bold, italics, emphasis, and span. Let me demonstrate the difference between block and inline now by using an example of an HTML file containing div and span elements. Okay, so I've opened Visual Studio Code here. I will now demonstrate an example where you will learn about document flow. First, I want you to notice that I have a div element containing 3 sentences of lorem ipsum. A div or divider element is used to divide content into sections. If you don't speak Latin, don't worry. Lorem ipsum is placeholder text that has been used since the 1500s. Each sentence contains a span element that you may recall are inline elements. Notice that all text is displayed in an unbroken flow of content in the browser. In the code, I have div and span elements. I am now going to change the middle sentence from a span to a div tag. Because the div tag is a block-level element, notice that the sentence has been moved to a new line and the span element after it is also on a new line. It's possible to change elements from block level to inline and vice versa. This can be done using the display CSS property. Let me add a CSS file called style.css. In my HTML file, let me give the middle sentence div element an ID. I now add a rule in the CSS file to change the element to an inline element. To create the CSS rule, I type #middle and open the curly brackets. On the next line, I type display : space inline semicolon, and on the next line, I close the curly brackets. Notice that the div has now changed to an inline element. If I want to change it back, I can just remove the property. I have deleted the rule in the code to change the element to an inline element. Another way to achieve this outcome is to set the display property to block. I have now changed the value for display to block. In another video, I'll demonstrate to you that there are other values you can set for the display property to change the layout behavior of an element. Congratulations, you have now learned about block and inline elements in HTML. It's important for developers to be comfortable working with each and to know the differences. It's vital to keep in mind that block elements start on a new line and span the entire page, and inline elements work within the flow of the surrounding content, rather than breaking onto their own line. If a car breaks down, you can open the hood to examine that engine and to find out what's gone wrong. As a developer, if your front end isn't working as expected, you can also open the hood to check what's going wrong. In fact, it's not just your own code that you can investigate. How about viewing other people's code? By the end of this video, you'll be able to access and make use of common web browser developer tools. Most web browsers come equipped with a set of developer tools that allow developers to inspect their HTML, CSS, and JavaScript code. Also, to trace HTTP requests to the web server, investigate performance issues, and review web page security. Let's find out more by exploring the homepage of the Little Lemon Cafe. To begin, I've just opened the Little Lemon Cafe's web page on my Chrome browser. On the home page, I can view their menu, but I want to explore the HTML structure of this menu. To do that, I need to open the developer tools. To open the developer tools in Chrome, press the F12 key on your keyboard for PC or Command-Option-J on Mac. Alternatively, you can right-click on the web page and select Inspect. There are various tabs on the top row of developer tools that provide different functionality. In this video, I'll give you a high-level explanation of some of the most used tools. First, let's open the Console tab. This tab outputs JavaScript logs and errors from your web application. The Sources tab shows all content resolved for the current page. It includes HTML, CSS, JavaScript images, and videos. With the Network tab, you can inspect the timeline and details of HTTP requests and responses for the web page. The Performance tab shows what the web browser is doing over time. It is useful if your web application is running slow because you can pinpoint the functions that are taking the most time. The Memory tab displays the parts of your code that are consuming the most resources. Finally, let's check the most used tab, the Elements tab. You can use this tab to inspect the document's HTML elements and their properties. For example, when I hover over an element in the Elements tab, it highlights that element in the browser pane. On the right side of the panel, there are tabs for inspecting the details of the elements further. This panel shows us what CSS is applied to an element and the result of the element displayed in the browser. You will explore these details in a later lesson. For now, you just need to know that if you click on an HTML element, then the information for that element will appear in the tab. Now, I'm going to demonstrate a fun trick. If you double-click the HTML, you can edit it in the web browser. For example, if I select the R menu body element, then I can change the first item in the menu from chicken burger to turkey burger. This doesn't change the content on the web server. It only updates it for me while the web page is open. If I open the web page again, it will reset. The web browser developer tools are a valuable part of your development toolkit to help you investigate and diagnose problems. And you now know how to access and make use of them. Great work. Think of a group of construction workers. Every worker has a toolbox that helps them get their job done. As a developer, you'll also use many tools. One of the main tools in your toolbox is the Integrated Development Environment, or IDE. By the end of this video, you'll be able to identify an IDE and explain the benefits of using an IDE during development. An Integrated Development Environment, or IDE, is software for building applications. An IDE is just like a text editor, except instead of writing documents, you're writing code. There are many IDEs available. Some are specific to one programming language, while others support many languages in one IDE. Let's explore some common IDE features. Here I'm working within an IDE. First, let's cover syntax highlighting. To improve readability for developers, IDEs have syntax highlighting. What this means is that special keywords of the programming language are highlighted in different colors so that the developer can quickly differentiate these keywords from other text. For example, if you're writing JavaScript code without syntax highlighting, it could be harder to identify keywords from other text. With syntax highlighting, that gets much easier because the JavaScript keywords and variables are colored differently. Now, let's explore error highlighting. Just like checking spelling in a text document, IDEs can highlight mistakes you make in your programming code. For example, if I delete the equal symbol where it's needed, my IDE will highlight the error. Another feature of IDEs is autocomplete. When you're typing a message on your phone, it suggests words as you type. An IDE's autocomplete is a similar feature. Since programming languages have special keywords, IDEs can offer suggestions to autocomplete words as you start typing them. Additionally, another feature called IntelliSense can make IDEs very smart and even able to understand your code. They can detect variables and functions and offer them as suggestions during autocomplete. For example, if I have a JavaScript function named myFunction defined at the top of a JavaScript file, then as soon as I start typing the letter M, my IDE suggests this function as an autocompletion. Then there is refactoring. Since IDEs understand your code, they can help you if you need to change it. To demonstrate how refactoring works, let's continue with the myFunction function that I defined a moment ago. In the code, the function is then called multiple times. It can also be called in the code of other files too. But what if you need to rename this function? You would need to rename it in every file that uses the function, ensuring that you update those files to use the new name. This process is known as refactoring, changing the structure of the code without changing the functionality. Doing this manually is very time-consuming and prone to error. If you mistype the new function name in one place, the application will break. Since the IDE understands your code, it can assist with refactoring and automatically update the function name across all files. That saves a lot of time. Let's rename our function now. I just right-click on the function and select Rename Symbol. Then I change it from my function to our function. The IDE then updates all references of that function name. IDEs come with a lot of other features to help investigate bugs and collaborate with other developers. Many even allow you to extend their functionality using plugins and extensions, but that's beyond the scope of this lesson. You have explored some features of IDEs in this video. You now know how IDEs operate as part of a developer's toolbox to write code more effectively. Well done.
You've reached the end of this introductory module on HTML and CSS. It's now time to review what you've learned over the course of these lessons. This module started with a lesson on the basics of HTML, or hypertext markup language. You began this lesson by exploring the answer to the question, what is HTML? And learned how to describe the purpose of HTML in a web browser, demonstrate the use of HTML tags, including how to ensure that you use the correct syntax, and identify how HTML elements like paragraph and image are utilized in a web document. And you also explored HTML documents in order to learn how to outline the structure of an HTML page, including the root, head, body, and other elements, demonstrate how to build basic HTML documents by combining common key elements and tags in order to create a structure, and explain how to create a link between HTML documents with the use of an href or hypertext reference attribute to redirect users between the documents. You then moved on to investigate the document object model, or DOM, a tree structure or model of objects in an HTML page. During your investigation of the DOM, you learned how to explain what the DOM is and the purpose that it serves within an HTML document, demonstrate how the DOM is created from a HTML page by exploring the elements that generate it and visualizing it in a diagram form, and provide a high-level description of common instances in which web developers interact with the DOM through JavaScript. These include updating content, setting up events, and animating HTML elements. And you also explored the concept of web accessibility by investigating how people with disabilities can understand, navigate, and interact with websites. You can now demonstrate a high-level knowledge of assistive technologies used to browse the web, like screen reader and speech recognition software, and make use of basic techniques to improve the accessibility of your web projects, such as correct HTML structure. Following this introduction to HTML, you then undertook a lesson in the basics of CSS, or cascading style sheets. The lesson began with an overview of selecting and styling, in which you learned how to explain what a CSS document is and how it interacts with the web browser, write CSS rules in order to style elements within an HTML document, and you also learned how to make use of different types of selectors, style text, and align text. In the final lesson in this module, you received instruction around developer tools. These are a set of tools available within web browsers that let developers inspect their code, investigate performance issues, and review web page security. You can now explain the purpose of web browser tools and demonstrate a high-level understanding of web browser tools, such as the console, source, and network tabs. You're now familiar with the basics of HTML, CSS, and web developer tools. Well done. You're making good progress on your React Native journey.